This is Algebra 2, Unit 10, Lesson 7, Natural Logs and Exponential Equations. We've talked about several different kinds of logs so far. Pretty much a log to almost any base we've studied already. And we've talked about changing logs from logarithmic form to exponential form. And if we were to do that for this one, the base is 2, logs equal exponents, so 2 to the third equals x. Would be how we simplify or solve that problem. So the answer to that we know would be x equals 8. For something like this, we said if you have a log and it doesn't have a base at all, it's a common log, which is understood to be a log base 10. And so understanding that no base number here would mean it's a log base 10, we could rewrite that in exponential form as 10 to the first equals 5x, and then 10 to the first is 10, so if we divide that by 5, x will be equal to 2. What we haven't talked about yet, though, is a log with a base of e. And in order to understand what a log base e is, you have to understand what the exponential function is, or the e function is. You, most of the time, will do exponential equations in the calculator. And exponential equations will be an e to a power. If you want to know what e itself equals, all you have to do is put it in the calculator. If you put this in the calculator, usually for most calculators, when you put the e button, you'll get a blinking cursor here where your exponent is supposed to be. And if you want to know what e is, like e to the first power, if you put that in your calculator, so e to the first is 2.718. I'm rounding to 3 decimal places. It does go on forever. But e is 2.718. Now, you don't have to have that memorized. You can always put it in the calculator or Desmos and figure out what that is. If they give you something like e to the second, or e to the 10th, or e to the 6th, those can all be put in Desmos to solve. So if I'm in Desmos and I want to do e to the first power, it tells me here. Now I could take that to a power of 1. It's 2.718. E to the second was the next one. That's 7.389. E to the 10th is 22,026.466. E to the 6th, 403.429. So it's very simple to put those into Desmos. If you have a log to the base e, then the base number there would be that 2.718. The reason we need to know log base e is because it's a special log. It's called a natural log. And natural logs are the inverse of the exponential equation e. And the nice thing about that is, since they're inverses, then they will undo each other. And so this will open up another set of equations that so far we haven't been able to solve, or we've been able to solve them, but they haven't been real easy to solve. Now, knowing how a natural log can undo an e, it will make those equations a lot simpler to solve. So we've said that a log base e of x is the same thing as a natural log of x. This is the notation for natural log, ln. And you have a log base 10 button on your calculator. You also have a ln, or a natural log button, on your calculator. The log button is a log base 10. The ln button is a log base e. And if we were to just think about this in terms of converting it to exponential form, we know that e is our base here. E to the power is what's on the other side, e to the natural log of x equals x. So if you look at what you've got here, if e to the natural log of x is equal to x, well, wouldn't that make sense that these two are inverses since x equals x? So whenever you have e to a natural log, they cancel each other out. They're inverses. So that gives us x equals x, showing that a log base e is, in fact, a natural log. If we have an equation that is going to be very difficult to solve by putting a log in front, sometimes, especially if it involves an e, if we understand that an e and a natural log cancel each other out, then instead of putting a log in front, sometimes we're going to put an e in front. Or instead of putting an e in front, sometimes we might put a natural log in front. And that will help us get rid of the e, the exponential equation. Another thing that you're going to have to do on your calculator is compute natural logs if they give you natural log to a number or of a number. you can put those in the calculator as well. So here I am back in Desmos. I'm going to put those natural log functions into Desmos. Natural log of 4 would be a 1.386. The natural log, and I'm just typing in the ln of 0.05 would be a negative 2.996. And then the last one was natural log of 3 gives me a 1.099. So again, I'm rounding all of those to 3 decimal places. So if you just have a natural log of a number, those are very simple to solve. They're calculator problems, round to 3 decimal places, and you're done. We said that a natural log is the same thing as a log base e. So if I have log base e of e squared equals 2, if we want to see if that's true, well, then can't we convert this log base e to exponential form? So we take the base e to the second equals the, what I call the x part. They are equal. So here we can see again that a natural log undoes an e. See, natural log of e to the second, the natural log and the e cancel, leaving us with 2 equals 2. Makes sense. Over here, we could do the same thing. Natural log is log base e of e to the 5th equals 5. Now, let's think about our properties of logs. Didn't we say a few sections ago that if we have a base that's the same as the base here, if we can get the two bases the same, didn't we say the log base e and the base e would cancel each other out, leaving us with 5 equals 5? That's another reason this works. We don't necessarily have to write it in exponential form. The log base e, or natural log, and the e, the exponential, will always cancel each other out, which is very nice when we're going to solve equations. And keep in mind, all of the rules for logs and exponentials that we've learned so far are still going to be true. So if we need to use properties to condense things, if we have two equations with natural log on each side, the natural logs would cancel out and the x parts would be equal to each other. All of those rules still apply. E is never going to be a variable anymore. E, you can assume from this point on in your math career, e is the exponential function, okay? Which would be e to the first, or 2.718, okay? Here we have e to the x power, and they're asking us to find x. So the question for all of these is going to be, what is the variable? Find the value of the variable, okay? And when you're working with natural logs and we're working with e's, if you have to round, just round to 3 decimal places, okay? Unless the directions tell you otherwise. Do whatever the directions in the practice problems tell you to do. In the notes, we're going to do 3 decimal places. So if you look at this, e to the x equals 6. Well, if e and natural log cancel each other out, and if we've learned when we were doing logarithmic equations that it's legal to put a log, as long as you do it in front of both sides, you're allowed to do that. Now, putting a log in front of each of these isn't going to help me, because a log e to the x equals 6, a log base 10, is not going to help me. But if I put a natural log in front, it will. Now, so not only can we put a log in front, we could put a natural log in front. You could put a log to base anything in front to solve it, but only 2 of them are going to really help you, a log base 10 or a natural log. Other logs with other bases don't necessarily help you solve the equations. That's why we didn't use them. So a log's not going to help me, but a natural log will. So if I put a natural log in front of both of these sides, natural log e to the x is equal to natural log of 6. I'm allowed to do that. I've done the same thing to both sides. Natural log of e is cancels out. That just leaves us with the exponent x. And that equals natural log of 6. So x is going to be what we get when we plug natural log of 6 into Desmos. That would be 1.792. So if I'm trying to solve this equation, if I move the negative 6 to the other side, I have natural log of 3x equals 6. So in order to get rid of the natural log, remember we said that a natural log and an e will cancel each other out. So if we think about that, if I have a natural log of 3x and I'm trying to get rid of the natural log, if you think about what that means, we talked about if we have a base that is the same as the base of the log. Now if you think about this, e to the natural log is the same thing as e to the log base e of 3x. So we said earlier in the chapter that if we have a base that is the same as the log base, those two things cancel each other out, leaving us with just that x part there. Remember we said if we have 7 to the log base 7 of 5, well that would just equal 5. Here, if I want to get rid of a natural log, all I have to do is put an e in front of it. So if I put an e in front, now remember, when we put e's in front, that means everything else becomes its exponent. So if I put an e in front here, I have to do the same thing on the other side, put an e in front, because if I do the same thing to both sides, it's legal in algebra. Now, if I just did it over here and got rid of the natural log, I would have changed the value of the problem. So I had to do it on both sides so I don't change the value of the problem. And so now e to the natural log of 3x is the same thing as e to the log base e of 3x. And the e and the natural log do cancel each other out. So I have 3x equals 403.429. I'm rounding to 3 decimal places. And if I divide that by 3, I have x equals 134.476. Keep in mind, a natural log is still a log, so all of our properties for logs will still apply. So if you have something like this is a log base e, this is also a log base e. Since we have a log or a natural log on both sides, the natural log part will cancel out, leaving us with just those x parts. So x plus 4 equals 7, so that gives us x equals 3. We still have to make sure whatever we get does not cause this to be a negative. If it becomes a negative, then we have to throw it out. If we plug 3 back in, that would be a positive 7. So we know it works. X equals 3 would be our answer. For this one, to get the natural log by itself, I'm going to divide both sides by 2. So that's natural log 3x equals 2. And now, to get rid of the natural log, what do I put in front of it? An e will get rid of a natural log. So if I put an e in front there, I have to put an e in front on the other side. The e and the natural log cancel each other out, leaving me with 3x. And then e squared is 7.389. And if I divide both sides by 3, I will get 2.463. If you have natural logs subtracted from each other, all of those properties still work. So for this, since those are both logs, I have natural log of x minus natural log of 3. That's the same thing as natural log of x over 3. I am still allowed to do that. And then I know that if I put an e in front, I can get rid of the natural log. I have to do that on both sides. The natural log and the e cancel out. I've got x over 3 equals 54.598. And again, you can do that in Desmos. And then if I multiply that by 3, I end up with 163.794. For this one, I have a natural log on the left and 2 natural logs on the right. That plus tells me I can multiply those together. So on the right-hand side, that's really natural log of 8x. That still equals natural log of x squared plus 12. Then my natural logs can drop out, leaving me with x squared plus 12 equals 8x. If I move the 8x to the other side, x squared minus 8x plus 12 equals 0. Factors of 12 that add to give you 8, that would be 2 and 6. The plus tells me they're both going to be subtraction signs. So I end up with x equals 2 and x equals 6 as my 2 answers. I do need to plug those back in. So if I plug 2 in, that gives me a positive number. 2 here is positive. If I plug 6 in, that's a positive, and that's a positive. So I can keep both of those. Remember, if they cause my x parts to be negative, I would have to throw them out. Okay, so what if our equation has an e in it instead of a natural log? Well, the same rule applies. We can put a natural log in front of an e to cancel it out, just like we can put an e in front of a natural log to cancel it out. So if you look at this, the first thing you have to do, I can't just put a natural log in front because I've got something in front here. So I need to take care of the 2 first. So I'm going to divide both sides by 2. When I do that, I have e to the 0.5x equals 45 over 2. Now, in order to solve this, or in order to get rid of the e, I can just put a natural log in front of both sides. So if I do that, natural log of e to the 0.5x equals natural log of 45 over 2. And the natural log cancels out the e. So I have a 0.5x equals natural log of 45 over 2, which is a 3.114 if I round. And if I divide that by 0.5, I end up with x equals 6.228. For this one, I have an e. the directions here will be to solve for t, get t by itself. I can't do anything with this e. I can't put a natural log in front until I get it alone on one side. So that's the first thing I'm going to have to do. So first I'm going to divide both sides by the 25. Then I'm going to subtract 1 minus 12 over 25. So that's going to be 13/25 equals a positive e to the t. It's easier not to have to deal with negatives, so that's why I did it that way. And then I can put a natural log in front of the e to get rid of it. So natural log of e to the t, I put a natural log in front of that side too. Natural log of 13 over 25 is a negative 0.654 equals t. For this one, I'm going to do the same thing. I need to divide by the 100. So I'm left with e to the 0.6x equals 20 over 100 is 1/5. Now if I put a natural log in front of both sides, I can get rid of the e. The natural log cancels the e, that's 0.6x equals natural log of 1/5 is negative 1.609. And if I divide that by 0.6, I have a negative 2.682. For this one, I have an e and I have a natural log. I need to do something with that 2. Unless the e is right beside the natural log, it won't cancel. So I have to figure out how to get that 2 out of the way. Well, if you think about your properties, when we were dealing with properties, if you have something in front of a log multiplied by that log, couldn't that go up here and be the exponent of the x? So isn't this the same thing as e to the natural log of x squared when I use my logarithmic properties, that power rule? So when I do that, now the e and the natural log are beside each other. That leaves me with x squared equals 16. And then if I take the square root of x squared, x would be equal to plus or minus 4. And then I can only keep the one that makes the natural log x part positive. So if I plug a 4 in, the natural log of 4 is a positive, but natural log of negative 4 would not be a positive, so I have to throw out the negative. My only answer there would be x equals positive 4. So here are 4 similar problems to ones that we've already done. Go ahead, copy these down, pause the video, try to do these, and then I'll give you the answers in a few minutes. So here are the answers. In this one, I'm going to use my properties to condense that a little bit. So I've got natural log of x over 3 equals 4. And so then I stuck an e in front of the natural log to get rid of it. So I have x over 3 equals e to the 4th is 54.598. And then 54.598 times 3 is 163.794. For this one, first I divided by the 2 to get it as simple as possible. E to the 2x equals 5. Then I stuck a natural log in front of both sides. The natural log and the e cancel, leaving me with 2x. Natural log of 5 is 1.609, so x is 0.805. In the next one, here I've got natural log of x plus 2 squared equals 6. If I put an e in front, that's going to cause this one to get pretty complicated pretty quickly, because that means I'm going to have to FOIL this and set it equal to a messy decimal. So instead of doing that, I decided to take the 2 and use my property, get the 2 in front, and then divide it over. That's going to save me a lot of work if I notice that that can be done. Because I would end up with getting some pretty nasty decimals down here. Some of them I'd have to throw out because they cause the x part to be negative. But I can alleviate that by getting the 2 out of there to begin with. Then I've got e to the natural log of x plus 2 equals e cubed, because remember 6 divided by 2 is 3. So that's where the e cubed came from. And then e and natural log cancel each other out, leaving me with x plus 2. E to the 3rd is 20.086. And then I subtract 2 to get 18.086. In this one, I used the properties in a different way. I took the 2 and put it here to make that x plus 1 squared, so that my e and my natural log would be beside each other and could be canceled out. So when I cancel those out, I get x plus 1 squared. That all still equals 4. Then if I square that or FOIL that, I have x squared plus 2x plus 1. I move the 4 over. X squared plus 2x minus 3 can be factored into x plus 3 and x minus 1. When I set those equal to 0, I get x equals negative 3 and x equals 1. Then I would have to check to make sure they don't make anything negative. The x equals negative 3 here causes this x plus 1 to be a negative, so I do have to throw that one out. So my only answer there would be x equals 1. This is a problem that we've learned how to do before, we learned that we could put a log in front of both sides and solve that. If we put a log in front of both sides and then use our properties to solve it and put it in the calculator, it worked. But I want to show you how natural logs work as well. You don't have to put a log base 10 in front. You can also put a natural log in front. So that is the same thing as natural log of 5 to the x equals natural log of 25. The x can be moved to the front. So a lot of these properties or a lot of these methods we've already used with logs when we plug a log in front. Now, what you don't want to do is plug a natural log in front on one side and a log in front on the other. You have to plug the same thing in front, okay? You can't do anything different. And then here, if I have x, if I divide by natural log of 5, I'd have x equals natural log of 25 over natural log of 5. And that can go into my calculator, and that's giving me a 2. And I do want to point out with this one, you should always try to find the easiest method possible. And if you know of an easier method than using logs, use it. We could also say, okay, this is 5x to the 5 squared, and no x equals 2. So we can check it doing that very easily. So you're not necessarily going to want a natural log or a log to be the first thing you think of. Sometimes you can do it easily in one step without logs, but if you don't recognize that, then logs will still work. So you can do it either way, but just keep in mind the most efficient way is probably the best way, but sometimes we don't always think of those efficient ways. For this one, the first thing I think I'm going to do, now our directions are to solve for x. First thing I'm going to do is get the 12 on the other side. I think that's the easiest thing to do. So I've got 1 minus 4 to the x equals 18 over 12. 6 goes into both of those, so that would be 3 halves. Then if let's move the 3 halves over here with a 1. So 1 minus 3 halves is negative 1 half, and that equals 4 to the x. I did it that way so that I could get the 4 to be positive instead of negative. I just think it's easier to work with positive base numbers. And then if I put a log in front, or let's do a natural log in front, now keep in mind that is one of our properties. That's x natural log of 4, right? Equals natural log of negative 1 half. Now if you think about that, we could divide the 4 over. So that's natural log of negative 1 half over natural log of 4. But hopefully you've noticed there's something wrong with this. You can't take a natural log of a negative 1 half. So natural log of negative 1 half, if you put it in the calculator, is going to give an imaginary number. It just doesn't work. So knowing that you can't have a negative here, hopefully when you see it right here, you would stop, because you can't have a natural log of a negative number. So that will happen sometimes. So for this one, the answer would be no solution. There's nothing I could put in there that would work, okay? If you're working in Delta Math and you have no solution, you would just leave an empty box and submit for a no solution problem. For this one, I could put a natural log in front and solve it fairly easily, but I could recognize that this is a base 4 and that 16 is also something I could get as a base 4. So remember, our old rules still work. You don't have to automatically go to logs or natural logs or e's to do these problems. The old methods work, so do whatever is easiest. So for this one, 4 to the x minus 3, and that equals, that's 4 squared on the bottom, so that would be 4 to the negative 2. So x minus 3 equals negative 2, so x would be equal to 1. So my answer there is x equals 1. That is probably by far the easiest method to use. The old methods still work. If you recognize that they're there, use them. They'll be much easier.